I'm going to record. Okay, so today we're going to be learning about Venn diagrams. So most of you probably know what a Venn diagram is, but basically they represent the intersection or lack of intersection between two or more groups. So a Venn diagram would look like this. So people who like to text versus people who like to talk face to face with their friends, right? So in the chat, do you like talking to your friends like face to face, or do you like to text them? Or yeah, that too, not having friends. Okay, so far I see 3 people who are saying both, right? And then 1, 2, 3, 4 people, or 3 people who have no friends. And then no one else, essentially. Okay, so 0 here and 0 here, right? So this is a valid Venn diagram, right? So there are 3 people in the intersection and there's 0 people outside. And then there are 3 people outside that. Okay. So we're going to be doing some practice with Venn diagrams. So copy link. So in the chat is a link. Click on that and make a copy. Okay, there will be like a lot of Venn diagrams essentially. And your goal is to complete it in the 5 minutes. So get to it. All 4 of them or 5 of them you completed? Okay. And putting them in the proper place. Okay, cool. Just sit and wait then. Okay, so sort these shapes. So there are 2 categories here, stripes and contains purple. So we can see that this circle is both of them. And then this one is also both of them. And then this contains stripes, but no purple. So this goes here. This doesn't contain stripes and it doesn't have purple. This contains purple, right? But has no stripes. Also, someone did ask earlier, what do you do if it doesn't fit in either? I did say you put it in the rectangle, so it would be like this one up here, right? Like, okay, like that one that's underneath everything. Okay, okay, so you would do the same with this. So you can see that there are stripes, but it doesn't contain purple again. And then this contains stripes and purple. And then we go so on. So this has neither stripes nor has purple. This has stripes and doesn't contain purple. This has purple, sorry, yeah. This has purple and stripes. This has stripes. This has stripes. This has stripes. This has no stripes. Sorry, it has no stripes and contains purple. no stripes, stripes and purple, again, stripes and purple, and then stripes and purple. This one, like the one at the very top, like this, that's pink. Yeah. Right. So technically this is a bit subjective, but like, yeah. Okay.
Okay, so for this one, it says circles versus contains pink. So for the first one, it's both a circle and it's pink, so it'd go here. No, like. And then this one is a circle with no pink, so it goes here. And then we have a circle again with no pink, and a pink circle, so it goes in the middle. And then another pink circle, another pink circle, and a pink circle with, no, a circle with pink stripes, a circle. This one is not a circle, but it's pink. This one is neither. This one is pink. This one is also pink. Neither. 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 Neither and neither.
Okay, so hopefully you all got that same answer. Okay, then for this one, the categories are contains green and or blue and not circles. So this is a circle, so it wouldn't go in the purple side, and it doesn't contain green or blue. So it is neither. And then this doesn't contain green or blue and is a circle, but this is a circle that contains green and that contains green. So it goes there. Then this is a circle that doesn't contain green or blue. This is a circle that doesn't contain green or blue. And same with this and this and this. But this is not a circle, right? And it doesn't contain green or blue. So it goes here. This isn't a circle. And it does contain green. So it would go here. This isn't a circle and does not contain green or blue. So it goes here, not a circle, doesn't contain green or blue, not a circle, but does contain green and or blue, not a circle. And then we just continue doing this. And you should, okay, actually this goes here. You should get this. Yeah. Okay.
So now we have a triple Venn diagram, so it's going to be harder. So basically, this one is not a polygon with equal side lengths. It doesn't have 4 sides and it does not contain red, so it goes here. And this one, again, goes here. So this time, this one contains red, so it goes here. This one, once again, doesn't contain red, and it's a circle, so this one too. And this one. And this one. And this one contains red, so it will go here. We're just gonna assume that this is an equilateral triangle, so it would have equal sides, so it goes, it goes here. Okay, never mind. Okay. And this one goes here as well. And so does this one. So this one is both contains red and has 4 sides. So it goes in this intersection. This one has 4 sides. Wait, actually, this one goes in the middle because it also has equal side lengths. And this one goes here. This one contains red 4 sides and equal side lengths, so it goes here. This one has 4 sides and contains red. This one, 4 sides, nothing else. This one, again, 4 sides, nothing else. And this one is 4 sides and contains red, so it goes here.
Okay, and the last of the examples, also let me just make this a bit bigger. Okay. So sort the shapes. Okay, so wait. Okay, so this one, okay, so the categories are circles, contains green, and no yellow. So this is a circle and it does not contain green, but it also doesn't have yellow. So it would go here. This is a circle that does not contain green, but does not contain yellow. So it would also go there. This is a circle that contains green and has no yellow. So it would go here. This is a circle. This one is orange.
I thought it contained yellow.
Yeah, it doesn't. It contains orange. I feel like I should have chosen better categories than colors. Yeah, okay. Okay, so this one is a circle that does not contain green, but also has no yellow. So it goes here. This is a circle, doesn't contain yellow, doesn't contain green, also here. This contains yellow, right? And it's a circle that doesn't contain green. So it goes here. This is a circle that does not contain green, but also does not contain yellow. So it would go here. And then this is a circle that contains yellow and no green. So it goes here. And then this is not a circle. It does not contain green, but it has no yellow. So it goes here. This contains green, is not a circle, but has no yellow and has no yellow. So it goes here. This is not a circle. This is not a circle. It contains yellow and does not contain green. So it goes here. This is not a circle. It doesn't contain yellow and does not contain green. This contains green, has no yellow, and is not a circle. This is not a circle, contains no yellow, and contains no green. This is, so we're just continuing. So this goes like here. Contains, this does not contain green, and it contains yellow. So it goes here. This contains green and no yellow and is not a circle. So it goes here. And then lastly, we have this one that does not contain green, that does not contain yellow, and isn't a circle. So it goes there. Okay. Orange is still not yellow. Yeah, this is a yellow and pink triangle. So it doesn't go in the no yellow category. So yeah. Okay. Besides some arguments about what colors are what colors, yeah, this is okay. We pretty much agree on everything else. So yeah, we went over these. Okay. Ruth, do you want to?
Yeah, so for terminology, there's union, which that's how you say it there. The union of X and Y is B.
It's okay, yeah, sorry. The union of X and Y would be A, B, and C. So it's like the combination of the two circles. You can see D is the outer area that's grayed out because it's not included in the union.
The intersection of x and y is B. The complement of x is C. And mutually exclusive is B, which basically means the intersection of x and y of B is 0.
Also, just to clarify, the complement of x would include C and D. So anything that's outside of the circle of x. The union is the combination of x and y. So the union and the complement are like, okay, never mind. So like the complement of x is just everything outside of it, and the union of x and y is everything inside two or more categories, or inside x and y. So we will be doing a Desmos with problems. So in the chat, I put a link. So it'll look like this. And yeah, so go there. Okay, I see 3 of you have already joined. So kudos to you. Okay. So as you can see, we have these problems. But we will be starting with number 1. Okay, so essentially we want you to be able to draw a Venn diagram, right? So essentially problem number 1 is, in my book collection, 7 books are solely fantasy and 3 are solely sci-fi. If 10 of my books are both and I own 23 books total, draw a Venn diagram for my book collection, right? So essentially, as we did in like the earlier thing where we had where we sorted shapes, right? Like apply that knowledge here. So you were able to create a Venn diagram using that kind of information. So try to do it using numerical information. And also I see that not a lot of you are doing this, but make sure you draw a rectangle around your Venn diagram to represent like the total complete space. And inside the rectangle, but outside the 2 circles, you should have the number of books that are neither sci-fi nor fantasy. Okay, so right now I'm seeing like 5, 6 good looking ones. Yeah. If you're using a computer where it's like kind of hard to draw, there are like shape icons you can use, I'm pretty sure, which could be helpful. Yeah. Okay, so I'm actually liking Aiden's Venn diagram. So we have 7 books that are solely fantasy, right? So they would be in the circle of fantasy, but outside the intersection of fantasy and sci-fi, right? Which he did. And then 3 books are solely sci-fi. So they're inside the circle of sci-fi, but outside the intersection. And 10 of the books are both, right? So we have 20 books that are in fantasy, sci-fi, and or both. And then we have 23 books total. So we have 3 books that are neither fantasy nor sci-fi. So 3 would go outside. So this Venn diagram looks really good for the problem. Yeah. Okay, also, just a reminder, you want to, when you're drawing a Venn diagram, you want to label the circles because they tell you what the numbers in each circle represents. And remember, again, you want to draw the rectangle outside of the circles. Okay. So I'm saying not a lot of you are labeling your circles in your Venn diagrams. So remember, label them. And remember, after you draw your Venn diagram, make sure that you are adding up the numbers to make sure it does add up correctly. Yeah, Charles, writing G and B is labeling. So yeah. Okay, so I like Schultz here. You have 17 friends, right? And 4 like green and blue. So 4 would be the intersection of green and blue, right? So he put that. And 3 like neither. So 3 would go outside the green and the blue, right? And we know we have 17 friends total. So we already have 7 accounted for. So 10 like only green or only blue, right? And we know that they're divided equally. So we just do 10 divided by 2 and we get 5 like only green and 5 like only blue, right? And now we have to ask ourselves how many of our friends like green, not how many of our friends only like green, right? So 5 plus 4 is 9, which he put. So good job. So 9 of your friends like green. Okay, problem 3. Remember, make sure you're drawing a rectangle around your Venn diagram. No name and yeah, other people. Yeah. Okay, so I see some of you are making the mistake of thinking 6 kids that are both tall and have brown hair are not included in the 20 kids that are tall and 13 kids that have brown hair. Right? So make sure you are accounting for that. Right? Because if they were like, if the 20 kids that are tall are only tall and the 13 kids that have brown hair only have brown hair, then the sum of 20, 13, and 6 would be greater than 35. And we know there are 35 kids in our class, and there aren't negative kids. So, you know, yeah, the math doesn't add up.
So do we just subtract 3 from both, or how do we know how many are?
Sorry, I did not catch that.
So like if the 6 is not separate, how do we know how many are on each side, or do we just assume that we subtract 3 on both sides?
Okay, so I'll go over that. So okay, I liked Advika's Venn diagram. So we know that the 6 kids are both tall and have brown hair, right? And we know that there are 20 total tall kids. So we know that if the 6 is included in the 20 kids, then the kids who are tall but do not have brown hair must be 20 minus 6, right? Because they have to add up to 20. So we know that 14 and 6 add up to 20. So there would be 14 tall kids, right? And then we also know that there are 13 kids that have brown hair, right? And we know that there are 6 kids in the intersection, right? So we do 13 minus 6 to find the number of kids who only have brown hair. And that would be equal to 7 kids, right? And we can add those up to find out how many kids are tall and or have brown hair. So we get 27. And we know that there are 35 total kids in my class, right? So if there are 27 total kids, if there are 35 total kids and we only have accounted for 27, that means that there are 8 kids we haven't accounted for. So we'd have to put them like in this space, in this rectangle, but they would be not included in tall or brown hair. So we would have 8 here. So does that answer your question? Okay. Okay, so okay, so my friend owns an ice cream shop and interviewed all the customers about their preference of cups to cones, to cups or cones. 29 and customers answered, and 17 said they only liked cones. If twice as many people liked cups than liked both equally, how many people liked both cones and cups, not only one or only the other? Yeah, your arguments are unique. Okay. So I'm seeing a lot of you have answered. Okay. So, your friend owns an ice cream shop and interviewed all the customers. So 29 customers answered, right? So we know 29 customers would be included in this space. Right? And 17 said they only liked cones, right? So we can create a Venn diagram here. And then we can say cups, right? This is a cup. And this is a cone, right? So your friend 17 said they only liked cones, right? So 17 people would be included here, and they won't be included in the intersection, and they won't be included in cones, in cups, and they won't be included outside in this outer region, right? Twice as many people liked cups than liked equally, than like them equally. Right, so we're gonna assume in this case that 0 people like neither, right? So we have 29 customers who answered. So that means that there are 12 people who either liked cups, who liked cones, right? Or liked both, right? So we have 12 people, and twice as many people liked cups than liked both equally. Okay, wait, sorry, I mislabeled this. Yeah, okay. But essentially we have 12, right? And 12 is equal to 2 equal, so 2 of both plus, okay, so we know that that twice as many people like cups than like both equally. So if we say B is the number of people who liked both equally, then 2B is the number of people who liked only cups, who liked only cups. So we would have 3B, right? Because B plus 2B is 3B, right? So we divide both sides by 3, and we get 4 is equal to the number of people who liked both cups and cones. Okay, did I like mess up because everyone put 8? Yeah, I got 4, right? Earlier I thought I saw a lot more people who put 8, but you know, yeah. Okay. Okay, so let me clear my annotations. Okay, and now we will be going on. Okay, do you all want to make things difficult, or do you want to do a Kahoot? Okay, there are just like 2 problems on this, right? So we will skip them, right? And do the Kahoot. So would you like to do the easy one, or would you like to do like the math one? Because we do have enough time to do both. Okay, yeah. Okay, we'll do both. Do you want to start with the easy one or the harder one? Okay. I'm seeing a lot of easy. Actually, no, I'm seeing a lot of hard. So I will start with the harder one. Wait. Give me a minute. In the meantime, how have your schools been so far? Have they been good? Okay, I can see none of you are having a good time at school. Yeah, I thought I'd like it more because I'd see my friends, but I actually don't. So, yeah. Oof. Okay, everybody, join the Kahoot. Okay, there should be like 14 of you. Like, please join.
Can you make it so that we can see the questions on our screen?
Yeah. Okay, yeah. It has it, so it's like that. Okay, there are 11 you in here. So, and by NA, it means the total. Um, yeah, it's 36. So in A, we have 3, we have 33. Yes, so as Shlok said, 33 plus 3 is 36. Yeah. Good job, William. Okay, so remember the intersection is where they overlap, so it's just 33 here. Yeah. So, yeah. I think most of this is just about being fast. So, okay, remember there's a difference between union and intersection. Okay, yeah, some of you put the intersection. Remember the union is the combination of A and B. So it's this, this, and this. It's everything that's in both of those circles, right? It's not whatever's in the intersection, right? The union, so intersection, you can think like the N in intersection stands for and then the U in union is like, okay, no, I was gonna say it's for both, but U and B are not the same, right? But you can, yeah, union is for both. Okay, so 4 of you got it wrong. So Advika has a streak of 3 correct answers. Okay, so the complement of A. I know we only covered these like terminology things at the beginning of class, but yeah. Okay, so some of you actually thought it was 13. Okay, so remember that this 11 down in this corner stands for other things, right? So like outside of A and B, but still in like that data set, right? So there are 11 people without brown hair or brown eyes, right? In this group of people. So we do 11 plus 13 and get 24. And that would actually be the answer. So I see you all had a variety of answers. Yeah, complement is just everything outside of A. So complement of A is everything outside of A. 3 players just dropped their answer streak. Ouch. Okay, so this is a bit more complex, right? So the intersection of B and A's complement. So it's asking about the intersection of B, not B's complement and A's complement, but B and A's complement. Oof. Okay, so it is 13. So the intersection of B and A's complement. So B, right, is this thing. And then A's complement is everything that is outside of this thing, right? Okay, that's beautiful. But like outside of this, right? So it would be everything that is not in the intersection of A and B, but is in B, right? So it would be 13. Right? So remember I said it's the intersection of A's complement and also B, right? It's not saying B's complement. I said that, but like y'all were probably like focusing on the problem or something, right? So yeah. This is like the harder Kahoot. The other one is just terminology. Yeah, this is like medium. Like, yeah. Okay, so the union of B's complement and A. So remember what union means. Okay, actually none of the answers are right. Yeah, yeah, just yeah, okay. So it's supposed to be the union of B's complement, right? So B's complement is 3 and 11 and A, right? But since it says union, you know, it's 33 plus 11. Okay, no, there was a right answer. It just wasn't correct. Okay, it was actually 47. Sorry to everyone who got it wrong, but got it right. Yeah. Okay, yeah. So the number of people who liked tea was 27. 16 plus 2 plus 8 plus 1. I'm assuming the person who put 26 did not add correctly. But yeah, 16 plus 2 plus 8 plus 1 is equal to 27. So we're almost done with this. So how many people do not like wine in this scenario? Okay, so the number of people that do not like wine is 38. So remember, we're doing 15 plus 2 plus 16 plus 5. So 31 plus 7 is 38. Also in the chat, don't bully or scam people. Yeah, be civil, like Addie said. Okay, so the number of people who like at least one drink is 56. So 16 plus so 8 plus 2 is 10. 15 plus 1 plus 4 is 20. So 20 plus 10 is 30, plus 10 is 40, plus 16 is 56. So yeah. So this is our last problem, and it's 8 o'clock. So you'll never get to do that easy one. Okay, some of you said no, they are not mutually exclusive, but because there's nothing there, you're supposed to assume that the intersection is 0. So the answer would be yes. So good job to Shlok, Aiden, and William. Good job. Okay. Good job, everybody. You can look over the slides, they'll be posted in class. If you want to like figure out how to do three-way Venn diagrams. And if you do not have any questions, feel free to leave now.